Welcome to this new video tutorial. I will show you how to build your own firmware for WisCam model. To start to work with the WisCam model, the first step that we must do is to load the source code that Rad Wireless did. For that, we must go to the GitHub page and search for the Rad Wireless. How we can see, the company has a lot of code that we can use, but this time we only will use the WisCam code. We can download the code by two forms. The first form is use a zip file, or we can use a Git code manager. For that, we must copy the URL, and in the Linux terminal, we need to write git clone and paste the URL, and then enter. Now the code is downloaded by the Git manager. When the code has been downloaded, we must enter to the folder. With vi command, we can open the README file. And how we can see, the manufacturer say that we must run a command first of all. That can help us to run the script for build the firmware. After this, we can build our first firmware. For that, we must write /script/build . The script will update Linux and download all the software, toolchains, create folder, and all that we need to use to compile the firmware. And after this, we'll create the firmware and the folders that we need to use to update the firmware to our model. This step will take a lot of time. If you want, you can take a cup of coffee. When the compilation has done, we go to the output folder. And into there must be AutoWriter folder. With ls command, we can check the files. The AutoWriter.exe program is the program that we must use to upload the firmware to our models. But this program only works on Windows. There will be, too, the new WisCam UAC video in. This part of the firmware helps us to use the WisCam like webcam when it's connected to the computer by USB port. How I said the first time, this command is for build the stock firmware. But if you want to create a special software for the WisCam module, we must go to another folder with cd source/applications, and into there are a lot of stock software and source. For our program, we need to create a new folder. with mkdir new software. I suggest you to copy a bulid script from a software to Word folder. With this method, will be create Word program by default, like RTSP server program. The script is built, and the command to copy is cp rtsp build to Word new software folder. And if we go to the new software folder, we can see the script to build the program. For create our first program, we need to create a main.c file. And into there, we write our program. In this case, a hello world program. Void main printf hola mundo or hello world in English. First, we need to be sure that our program works. For that, we use a gcc main.c-o and the name of the program, test x86, and then run it with ./testx86. The program shows us hello world or hola mundo. We can upgrade the program because the program has no returner line jumps, but this can be fixed only with /n where we can want to jump. Now we can add /n at the start of the word and the end of the word. Now the program shows us the message how we want. Now that we know the program works, we must create the script that builds the program into the firmware. Recently, we have copied the build script from RTSP server. We enter and change it for our program. There are some parts that we don't need it now. First, we need to know in which folder we are. For that, we write a variable and the command pwbd. And now we have the main path. If we want to build a program for ARM processor, we must not use GCC. We need to use ARM Linux GCC, the main path /main.c. With the output main path /test_rmm. Now we have an ARM program, but we must copy the program into the folder that the main script used to build the firmware. We use cp mainpath /test_rmm and we copy the program into the destination folder that is designed by the console command. install path /bin /. And with this modification, we have our program into the installation folder. We save it, and we must say to the main script that must use the new script from our program. We go back and open the script build all. Into the build set, we must put the program that we want to build. New software and space. Please don't forget the space, because without this the script will fail. We save it and go back to the main folder. We execute the build script and will generate the program and the firmware after some minutes. Now that the program has been generated, we can check it and test it to know if the program is okay. We go back to source /apb fs /new WisCam /bin, and with the command ls we can see if our program is into the folder. Test rm. For check our program, we can use the command file test ram, and the program shows us how the program has been compiled. The program is for ARM processor and dynamic linked, and that means that the program finds into the firmware for the library that needed. How is a very little program, I think that we don't need a static link program. If we check the RTSP server program, we can see that the program is compiled with static flag. That means that this program has all the functions that need into the program. We go back to the main folder and go into the output folder. Autowriter, and there is our software. We need to copy all the Autowriter folder into the Windows computer. With this we can upload the new firmware to our module. This is the new module WisCam. My first test of this was different. Now it has more ports. For update the firmware, we must search the debug pins. This is the debug pins. We need to close these two pins. But if we won't solder those pins, we can use a very easy trick. This is Arduino Uno module. We can use it because it has these pins that are connected. We can take the WisCam module, we turn it around, and look into the board. We know that we must use the first 3 pins. This is the debug port. And now we only need to connect the USB port to the Windows computer. How I said before, we only need is to execute the autowriter program and say us that we must connect the board to the computer by USB. How I am in the virtual machine, I say that must be connected to the virtual machine. Now is erasing the firmware. If you are not using a virtual machine, this step will take less time. Now the firmware has been installed and we can unplug it and test it. The next step uses the Wi-Fi network from the module and logging it by telnet, like the first video tutorial. Telnet 192.168.1.0.0.1. With ls command, we can see that our program has been installed. Test ARM. We execute the program by /test ARM. Now the program has returned an error. I made a mistake, because I told you that it's not necessary to build a program with a static library. But there are not a lot of shared library on the firmware. We can fix it. We must enter to the program folder with cc source applications new software. BIM build, and in the line that there are RM Linux TCC, in the end of this line we must put static. With this, our program will be compiled with a static library. And now we will execute the build script again. The build script must be used for create all the firmware. But if we want to test only our program, we can update it by program TFTP, and we don't need to use autowriter. This method is better for debugging and testing. Now that our program has been created by a static library, we can test it. For that, we must use the telnet command, and with the ls we can check if the program is into the module. By /test ARM, we can see that now it's working. Now we know that how to create our own programs and how to include it into the firmware. I hope that this tutorial has been clear, and in the next video I will show you another program and products. If you like this video, subscribe it.